Hi, and welcome to this Ignite webcast. My name is Josh Topal, and I work on the Office 365 team. And if this is your first time, welcome. And Ignite events are a series of technical workshops for IT professionals and Microsoft partners. And the Ignite webcast will address different subjects and scenarios that are really beneficial to anyone who wants to increase their knowledge of the Office 365 suite. So today we're really excited to have Jeff Mealiffe lead our webcast. Jeff is a Principal Program Manager lead for Office 365 at Microsoft, and in today's webcast, Jeff will be discussing Exchange Virtualization. So again, today's session provides a really good opportunity for you to hear directly from a Microsoft employee and someone who's worked so closely on the Office 365 product. We will be taking questions from the audience today, so you can go ahead and type those into the link chat window. We do ask that you hold all your questions to the end. We're going to have about 10-15 minutes for a Q&A. And we are recording today's session, so we'll have the slideshow that you're going to see and the video available online on the Ignite site, and I'll post a link to that real soon. And one last thing, though, is that since we are recording today's session, please understand that you may be captured in the meeting. So if you don't wish to be captured, make sure you don't type anything in the IM window. And also, if you really don't want to be captured, feel free to leave, and you can view the recording at a later time right here. There's the link. So that's it for me, and so Jeff, whenever you're ready.
Great, thanks, Josh. So my name is Jeff Mealiffe. As Brian mentioned, I'm a program manager working on Office 365 and really on a number of different areas. But for the purposes of today's call, I'm the program manager for Exchange Virtualization. So I'm responsible for setting support policy, coming up with best practices guidance, working with our content publishing team to get documentation out, and presenting this type of content at events worldwide. And I've had a lot of fun doing that over the years. I've been at Microsoft for about 13 years, and all that time have primarily been focused on Exchange, performance, scalability, virtualization, compatibility with hardware, that type of thing. So we'll go ahead and jump in. I'm really happy to be here today. This is a great opportunity to provide this content to those of you on the call today, as well as anyone listening to the recording later on. This information does change over time, so it's always great to be able to have another opportunity to get the current best practices out in front of our customers and partners. So as Josh mentioned, we are going to have time for questions at the end. Let's see if we can get my slide to move there. Yep. And because of the way Link is set up on my desktop at the moment, I'm actually sharing my desktop, my entire desktop view. So I'm not going to be able to see your questions until the end. So just be aware that I'm not going to be able to stop in the middle and answer anything pressing, and we'll try and make sure we have time for that once I'm done. So we're going to walk through today just kind of a high-level overview of ways in which virtualization may or may not make sense for an on-premises deployment of Exchange. There's a number of different reasons that customers typically do or don't virtualize, and I'll go through some of those just to kind of put some ideas in your head and give you some thoughts from the product group's perspective on when it might be a good idea or when it might not. We'll talk about supportability. That's certainly very important. You want to make sure that when you're deploying a mission-critical product like Exchange, that you're doing it in a supportable way that Microsoft and our partners can help you with when there's problems. There's certainly lots of ways that you can deploy Exchange and other similar products, given the flexibility inherent in those products. But you want to make sure that wherever possible, you're doing it based on the published supportability guidelines. We'll briefly talk about sizing. There are some things to be aware of when it comes to sizing a virtualized deployment of the Exchange product that kind of go above and beyond just the basic sizing considerations for any deployment of Exchange. But in general, we've tried to make sizing for a virtualized deployment as simple as possible and as aligned as possible with the methodology for sizing the physical product. There's a great blog article out there written by me, a little biased on that, but it's designed to basically walk through start to finish the process for sizing Exchange 2013. And that's really the starting point for any deployment, including a virtualized one. But we'll spend a few minutes today talking about the minor tweaks that you need to make to that if you do virtualize. And then we'll talk about some common problem areas. One of the other things that I work on in my role is customer escalations. And I certainly see a lot of issues, both with virtualized and non-virtualized Exchange deployments coming through my team. And given some of that experience, I'll go through some of the common problems that we see in the field today and how you can avoid them. So really key to understand, virtualization of Exchange, absolutely supported. There are a few caveats that we'll talk about today. And in order to have a very healthy Exchange deployment that you're happy with, that doesn't keep you up at night, and that your users are happy with, provides them great end user experience, great performance, great quick message delivery, using the best practices that we've published around virtualization and really across the board for the entire product, extremely important to having a healthy Exchange deployment. So we'll jump into why and why not customers often virtualize. So when we think about why, oh, that's interesting. Didn't notice that in the slides until just now. Well, ignore those first two bullet points. So why do customers typically virtualize? There's a number of optimizations around deployment. Certainly, when you think about virtualizing anything these days, one of the typical reasons that you're doing that is to kind of have a set of homogeneous infrastructure that you can use for all of your IT needs, right? You have basically resources that you can configure out of some, you could call it a private cloud or just a cloud in general. And your application defines what the resources are that you need. You don't need to go think about, well, how many physical servers do I need to buy? How am I going to configure memory on those to be, to optimize for cost and the needs of my application? How am I going to configure storage to meet those needs? How am I going to configure my network to meet those needs? Instead, the application defines what it requires. And Exchange actually does a great job of proactively doing that via the sizing calculator that we have available, as well as the sizing guidance that describes how the calculator works. And then taking those requirements, you can then go provision those resources out of that cloud environment and light up the application. That's certainly a pretty compelling deployment optimization or way to deploy an application versus having to go through a hardware procurement cycle and think through that entire process of how much hardware do I need, how do I plan for growth, how do I make sure that I'm going to have the hardware that I need when I need it. Obviously, you still need to have those resources available in that cloud environment, in that virtualized deployment, in order to be able to allocate them on demand to applications. But at the same time, if you've made the choice to go down that path of having allocatable resources like that, that's certainly a very beneficial thing. There's certainly optimizations around management, right? If you're deploying applications in this way, you now have a new management layer that you can use to manage all of your IT infrastructure, regardless of the application or the service that's running on it. Same goes for monitoring. Have some standard monitoring infrastructure to understand whether all those virtual machines, all those servers that would have been physical servers previously, are up and running, and to some extent whether they're healthy. Certainly there's varying levels of connectivity between that monitoring layer at the hypervisor level and the type of monitoring data that's actually available in a service or a server application like Exchange. Oftentimes that level of connectivity is pretty low, and so the monitoring that you get is really more about whether the virtual machine is up and running, whether the operating system is active, and doesn't really go into any sort of application level diagnostics. I'd say it's probably most common to hear customers talking about virtualizing to try and get better utilization of hardware. And that's really kind of aligned with cost as well on the slide. Certainly both of those two items are certainly cost is key in everyone's mind. We want to be able to provide these services to our end users at the lowest cost possible, while at the same time providing high availability and a good experience. And being able to take advantage of underutilized hardware, perhaps being able to dynamically move workloads around between machines, certainly a compelling reason to consider virtualization. And in many cases, we certainly are aware that the customers over the years have over-deployed hardware for Exchange and have an interest in consolidating. It's fair to say that let me untag that. Oh, I missed it. It's fair to say that Exchange 2010 to some extent and 2013 to a larger extent is actually really well designed to take great advantage of hardware. In other words, when you think about the resource requirements that the application has, it's trying to utilize kind of a balanced set of the resources on the box. So we're trying not to leave anything on the table in a physical deployment. So we do think that in the 2013 release, this becomes a little bit less of an issue. Still, you certainly can deploy too much hardware for 2013. There's no question about that, and you could potentially then virtualize that deployment and get some of those resources back. But important to be aware that compared to previous releases, we do think that hardware utilization perhaps becomes less of a reason to virtualize Exchange. Why not? Why wouldn't you virtualize? Well, complexity is a big reason. We've been talking for many releases of the Exchange product about a desire to reduce complexity of deployments. Every time you increase the complexity of a deployment, you're reducing or potentially reducing your availability. Obviously, there are ways to mitigate additional complexity in a deployment and maintain high availability, but you're opening yourself up to risk, basically increased risk of failure of the deployment. So wherever possible, we want to avoid complexity. We want to avoid additional layers in the stack. And virtualization is really adding an additional layer. It's adding an additional layer in between the operating system and the hypervisor, right? In the case of Hyper-V, you're actually essentially running an operating system that supports a hypervisor, and then within that, multiple operating system instances for each one of the virtual machines. That's additional complexity. The storage infrastructure behind a virtualized deployment can and often is more complex than some of the more simple storage options that Exchange 2013 supports. So we could talk about complexity all day long. Just be aware that when you go down the virtualization path, you typically are adding some level of complexity. There are obviously additional deployment steps that come from the management layer, the monitoring layer, the hypervisor that if that is already set up and already configured in a private cloud deployment, you're good to go. That's really not so much of an issue. But if you are deploying a greenfield, brand new, fresh deployment, that's going to require some additional time, some additional configuration, and understanding to get that up and running properly. There is certainly a performance impact to virtualizing anything, and there's certainly marketing material out there today out in the world that talks about Exchange or other applications running better virtualized than on physical hardware, and that's you can kind of manipulate the data to correlate with that statement, but in reality, it's not true. There is absolutely a performance impact to virtualization, regardless of the hypervisor being used, whether it's Hyper-V, VMware, Xen, any one of the many hypervisors we support. There is going to be some additional overhead, typically when you think about CPU, right? You're adding an additional layer of software into the stack, and that layer is going to have some impact. We talk in our guidance about the impact from Hyper-V, and I'll mention that specifically in a minute. But each one of our partners in this space who provide one of the supported hypervisors has guidance around how to think about the performance impact of virtualizing. So just be aware of that. And performance impact does mean that there's some additional cost as well. Oftentimes, we hear that people don't virtualize because of unsupportability or incompatibilities with certain workloads. This used to be a problem with Exchange. Exchange used to have a number of very desirable features or entire component areas like unified messaging that were not supported for virtualization. And so that was a common reason not to virtualize. That's less of an issue with Exchange these days, but continues to be an issue with some other workloads. And then cost is on this slide as well. when you think about added complexity, you think about performance impact and actually potentially needing to deploy more hardware in order to virtualize. When you think about potential cost differences around storage infrastructure, whether it's a difference between a private cloud deployment that has some shared storage available to all the hypervisor nodes in order to be able to move those workloads around dynamically, compared to a physical Exchange deployment with direct attached storage, potentially JBOD. Oftentimes the storage cost can be very, very different between a virtual deployment and a physical deployment. So those are a few of the reasons why and why not. When you think about what the right answer is, there isn't really a clear answer for everyone. And ideally, we really want our customers and partners to pick the simple solution. We think you're going to have the best possible deployment of Exchange if you go for simplicity, right? Eliminate as much complexity as possible. That's the key. If you have a relatively small deployment where you can't truly take advantage of the type of server hardware that's available in the market today, well, there's a couple of options for you. One of them is certainly a virtualized on-premises deployment. The cloud is another option. That's certainly worth considering as well. But if you want your data on premises, if you want that level of control, it's certainly hard for me to argue against a virtualized deployment, especially if you already have the infrastructure deployed and you're just allocating resources out of a shared pool. So be aware of that. As you start to scale up, physical becomes oftentimes the simplest and in many cases, least expensive solution when you start being able to fully take advantage of physical hardware. So there's really kind of a continuum where you look at the number of users being deployed and the amount of load that those users are placing on the system. And once you reach the point where, in order to meet the requirement, you're allocating enough hardware or enough resources that you can fully load up some physical servers, virtualization starts to become questionable as the right choice. Obviously, there are other reasons that may override that, but if you're just looking at hardware utilization, that's really what to think about. So we recognize that virtualization absolutely makes sense for Exchange and really any application in this space for a subset of our customers. It's not for everybody. We don't think it's for everyone, but it does make sense certainly for some. And we do want people to get something out of it if they go down that path. What do I mean by that? So virtualization adds a bunch of very cool functionality from an IT perspective. The ability to migrate a workload from machine to machine, the ability to automatically bring a virtual machine online after a hardware failure on another physical hypervisor node. The ability to virtualize some of the network infrastructure and take advantage of some of the add-ons that provide extra benefits around the networking layer. There's many potential ways that a virtualized deployment can provide additional value over just a simple physical deployment. We want to make sure that if you do go down the path of virtualizing, that you're actually able to take advantage of some of those abilities, and that you're getting some return on that investment in the virtual deployment. So I'll stop there with the thoughts about why and why not. Hopefully that gave you some things to think about, and we'll jump into supportability. So before I go into specifics around supportability, I do want to call out one particular thing, and that's Windows Server 2012, and certainly Windows Server 2012 R2 now that's now becoming available. So Server 2012 Hyper-V has added a lot of new features, some of which are relevant for Exchange, some of which aren't. But I think probably the most exciting area of change or improvement for me is around some of what I would consider deployment blockers for Exchange on Hyper-V. Prior to Server 2012, Hyper-V had a limit of 4 virtual CPUs per virtual machine, and that caused a number of challenges for Exchange deployment. Certainly, deployment of any sort of Exchange configuration at scale, because typically Exchange servers at scale have far more than 8 CPUs available to them. Customers these days are typically deploying 8, 12, 16 core machines to run Exchange. And requiring that that deployment in Hyper-V actually divide up those machines into more servers with that limit of 4 virtual CPUs meant a lot of increased complexity, a lot of additional server licenses needing to be purchased, and it was very difficult to argue that the deployment in Hyper-V made sense, given that limitation. That limit is no longer in place in Server 2012. So I think that Server 2012 is a much better place to consider virtualizing Exchange 2013. Additionally, there is an increase in the amount of per virtual machine memory that can be assigned, and that's actually relatively important for Exchange Server 2013 as a fairly memory-hungry server application. I won't go into detail about how memory-hungry we are. Like I said, we've got a blog post out on the web about sizing the product, and we also have a calculator that you can use to understand the specific requirements given your user profiles and user counts. But this is helpful to us in Server 2012 to be able to increase that per virtual machine memory. We do think that deploying on Hyper-V 2012 is a great way to consider virtualizing Exchange. We certainly hope that folks who've been on other hypervisors previously will consider it. It in many ways is, I would argue, the most tested virtualized deployment of Exchange anywhere, and I'll talk to why that is. So we use Hyper-V internally, probably no surprise there, given that it's certainly a Microsoft product. But the vast majority, and I would say probably 99%, maybe close to 100% of the tests that we run on the Exchange product are run in a fairly large, what you might consider a private cloud, but a large pool of test resources that are allocated using Hyper-V and spun up and spun down thousands of times a day. Machines are constantly being rebuilt, reimaged, reused to run many test cases, thousands, tens of thousands, hundreds of thousands of test cases every day on each one of the changes that are being applied to the Exchange product. So we get great test coverage on the Exchange product running on Hyper-V throughout our development cycle. We also have a very close relationship with the Hyper-V team, right? They sit on the same campus that we do. We talk about new features. We talk about what does and does not make sense for Exchange so that we can have a good understanding of product direction within both of those teams. So we like Hyper-V. We think it's a great way to virtualize Exchange. So with that, I'll jump into a little bit of specifics around supportability. So when you think about hypervisors that can be used to virtualize Exchange, we've actually simplified our guidance in this area recently. There's an update made to the TechNet page that's actually pointed to in that link on the screen, the aka.ms/e2013virt link. We published a link or an update earlier in the week to that page that simplifies versions of Hyper-V that are supported to just say any version of Hyper-V. So the specific implication there is that as Server 2012 R2 becomes available, it's certainly an option, a supported option for a hypervisor for Exchange 2013. Now, that doesn't mean that Exchange 2013 can be run directly on Server 2012 R2. That's important to be aware of. You can use it as a hypervisor, but the supportability for the operating system that Exchange is directly installed on is a different story that we won't talk about today. It's a different conversation. But Server 2012 R2, absolutely a supported hypervisor. We also support third-party hypervisors via the Windows Server Virtualization Validation Program, the SVVP. And what that is essentially a program that our partners in this space have the option of participating in that provides supportability for Windows Server as well as various Microsoft Server applications that have chosen to participate in the program, including Exchange. So if one of our partners, such as VMware, has gone through the process of certifying a specific version of their hypervisor in combination with a specific version of the Windows operating system, that is a supported deployment platform for Exchange 2013. There's a great website that's pointed to via the link that I have down there, our General Exchange Supportability link, where you can go in and take a look at which specific hypervisor versions are supported with which specific versions of Windows Server. So if you are going to use a third-party hypervisor, it's important to go take a look at that. There's a wizard out there that you can use that will actually allow you to select which hypervisor you have, which version of it, and which version of Windows, and it'll provide specific supportability guidance for your deployment scenario. So highly encourage you to take a look at that if you're in that situation. When it comes to Exchange, all roles of Exchange 2013 are supported. That's pretty easy for us. We only have 2 roles now, but Mailbox and CAS absolutely supported for virtualization. For storage, essentially the same requirements that we've had for prior releases of Exchange. The storage needs to be block level. If you're using virtual hard disks or VMDKs, they need to be fixed in size, not dynamically expanding. We go into a fair amount of detail on the TechNet site in terms of what the specific requirements are around storage. Highly encourage you to take a look at that, and I'll explain what that asterisk is after the same requirements as 2010 comment is there in just a second. Around host-based clustering, and what I mean by that is the ability to have a set of hypervisor hosts that are all members of a cluster and can fail over virtual machines as cluster resources between those hypervisor hosts. We absolutely support that as well for Exchange. So important to be aware of that. And I'll talk about some considerations around that and when it does and perhaps doesn't make sense to use that technology in a few minutes. When we think about migration, and what I'm talking about there are things like live migration, vMotion, the ability to move a running virtual machine between hypervisor hosts without impacting end users. We also support that for all Exchange 2013 roles. And I'll also talk about some considerations around that and best practices in a few minutes. Jet stress testing also absolutely supported. Check the support guidance site for specific details on that, but we do absolutely encourage everyone to run jet stress in their virtual machines before actually deploying Exchange into production, just to make sure that the storage subsystem sitting behind that virtual infrastructure is able to meet the demands of Exchange. Even though we do continue to reduce our I/O requirements within the product, release over release, we are still very reliant on low latency storage and getting those IOPS that we require based on the sizing guidance. So be aware of that. So what's up with the asterisk? We have made a decision in Exchange 2013 to support VHD storage on SMB 3.0 file shares. So SMB 3.0 is new SMB technology that's available in Server 2012 and 2012 R2. And what this means, essentially, is that you can configure Server 2012 to share out storage, potentially in a highly available way, potentially using spaces and other new storage technology in Server 2012, and do that in a way that can be used by Exchange virtual machines with their VHD storage on those shares, and potentially save some cost, some storage cost, versus other types of shared storage methodologies. There are certainly other storage vendors, storage partners in the space who are making SMB 3.0 an option for presenting storage from their devices to hypervisor hosts as well, and those would certainly be supported as part of this also. So this is very specific to VHD storage. You can't take an Exchange server, as an example, and configure its mailbox database path to be a UNC path that's on an SMB 3.0 share. That doesn't work. And the commandlets that allow you to configure that will actually block that. All we're talking about here is storing a VHD file on that SMB 3.0 share and exposing that VHD as a storage device to an Exchange server. So Exchange just sees what it thinks is a typical physical storage device, and it doesn't it's unaware of where that storage actually lives behind the scenes. So that is absolutely supported. We do want to make sure that you think about high availability when considering this type of deployment option. There are different ways to deploy SMB 3.0 with Server 2012, depending on the level of scalability and high availability that you want to get. So it's worth taking a look at some of the SMB 3.0 deployment guidance that's out there from the Windows team to understand what those options are, what the levels of availability are that are associated with those options, and make a decision based on what those options look like. Why not NFS, which is, you can think of it as a competing technology to SMB. Why don't we support NFS? This is a very common question that I get. And the answer really comes down to kind of a lack of control. So NFS is a standard that has a number of implementations. Some of those implementations are great, some of them are less great. And there's also some limitations in the protocol itself that Exchange basically needs from a storage perspective in order to ensure reliable utilization of that storage behind the scenes. So when we think about good and bad implementations, certainly Windows used to have, I don't know if they still do, an implementation of NFS in the box. I'm guessing that our implementation probably not so great compared to some of the others that are out there. But the key thing to be aware of here is that because we can't go through each implementation of NFS and understand whether or not it meets the specific requirements of Exchange, we can't feel confident that deploying Exchange on a particular implementation of NFS will result in success. We've seen issues around performance and we've seen issues around reliability, potentially including data loss or massive amounts of reseeding when you think about a database availability group that have led us down this path. And this is, not new. This has certainly been something that we haven't supported even prior to virtualization being in the picture with the Exchange product in the past. So that's the background there. We have made the decision to move forward with SMB 3.0 because we've done extensive testing internally to feel confident that you'll have a great experience if you decide to go down that path, but we don't have that confidence with NFS generally. So that's why we've elected to not support it for Exchange storage. So when we think about migration, I mentioned that migration is absolutely supported for Exchange roles, live migration, vMotion, similar technologies from other third-party hypervisor vendors. There's a lot of confusion in this space, and I've certainly gotten a lot of questions from both from the Microsoft field and directly from customers over the years around what is and is not supported. There's some language out in our supportability guidance that continues to get tweaked every time we release an update to that guidance that hopefully gets more and more clear over time. It's, I'm sure, not perfect today, but the key thing to remember here is that as long as the virtual machine stays online while you're migrating it, basically as long as time continues moving forward while that migration is happening, it's supported. What we don't support in this area are technologies that take basically a point-in-time snapshot of a machine, basically pause the machine, and write the state of that machine down to disk. So take a copy of the memory, write it to disk, move that virtual machine to another hypervisor host, and then bring it back online, as if nothing happened. So time wasn't constant in that type of scenario. And that's where we run into problems with Exchange. And that's the type of migration that isn't supported. HyperV's technology for this is called quick migration. It's something that we had available before live migration came into being. It is not supported with Exchange. Any sort of distributed system, and Exchange is certainly a distributed system when you think about the ways that it replicates data between machines in a deployment. Any sort of distributed system is going to have challenges with one of the machines in that system just disappearing for a period of time and then coming back online as if nothing happened. Exchange is no exception to that, and that's really why we don't support quick migration or similar technologies. So, key thing to remember, as long as the virtual machine stays online and continues operating during the migration, absolutely supported. So when we think about things, other areas that we don't support, dynamic memory, memory overcommit, memory reclamation, any sort of technology that is changing the amount of memory that's available to a virtual machine behind the scenes, those are all unsupported for Exchange 2013. We recommended strongly against using them with Exchange 2010, but for 2013, we're coming out and just saying not supported. This is a huge pain point for our customers in the 2010 release, and we want to make sure that it's not going to continue to be a pain point with 2013. The way to avoid these problems, and I'll describe what those problems look like in a couple of minutes, the way to avoid them is to configure static memory for Exchange virtual machines. And that means that the amount of memory that's available to an Exchange VM is the amount of memory that it has at the start, the amount of memory that it has at the end. Memory doesn't change, and all that memory is backed by physical memory on the hypervisor host. That's the key. We don't support hypervisor snapshots. We're not talking about backup there. We're talking about the ability to essentially take a point-in-time snapshot of a virtual machine that you can then roll back to at some point in the future. We don't support that for production. I would argue that that's probably critical technology for any sort of a test lab or a pre-production lab that you might build. And I certainly use this with Exchange on a daily basis in some of the testing that I do. So I highly encourage you to use it in that scenario, but in production, we don't support it. And we also don't support the storage technology that sits underneath snapshots, which would be differencing or delta disks, essentially for the reason that we don't support snapshots. We don't support running applications on the root, and this is really more of a Hyper-V thing than anything else. What this essentially means is don't deploy Hyper-V on a physical host and then also deploy SQL on that same physical host running alongside a bunch of virtual machines, or really any other application other than monitoring, management, antivirus, things that you would typically deploy on a server in your data center. The reason for that with Hyper-V is that root instance of the operating system gets resources allocated to it in a different way than the virtual machines that are running on the host. And we want to make sure that the Exchange virtual machines that you're running have access to the resources they need when they need them. That's really the key there. And we also don't support significant processor oversubscription. So this refers to the ability to assign more virtual CPUs to the virtual machines running on a host than actually are physically available on that hardware. We support up to 2-to-1 oversubscription, but we actually recommend 1-to-1. That is not oversubscribing that CPU resource at all. I'll talk about why that is in a couple minutes. So around migration, this is actually more of a HyperV Replica consideration than a migration consideration, but it falls kind of into the same bucket because people think about it in a similar way. It's important to be aware that HyperV Replica is not supported for Exchange currently. HyperV Replica is a feature that came along with Server 2012 that provides disaster recovery really to any virtualized workload. It's essentially doing log shipping at the virtual machine layer so that as changes are made to virtualized storage, those changes are applied to a virtual machine, ideally in a secondary site. So that if you lose the first site, you have a virtual machine that can be brought up in a secondary site relatively quickly. And that's great for applications that don't have built-in DR. Exchange does have built-in DR with a DAG, and you're going to get the best disaster recovery and the best high availability from using the functionality that's native to the Exchange product. So we think the replica absolutely makes sense for other applications. We don't think it makes sense for Exchange today, and that's really the thing we want you to understand. Around sizing, this is really interesting. My slide titles are a little bit off here. So this is really around CPU sizing, why not NFS. So we want you to plan to add additional CPU overhead on your Exchange virtual machines, typically around 10% for Hyper-V, and that's what our sizing calculator will actually calculate for you if you choose to specify that you're virtualizing. If you are using a third-party hypervisor, we recommend following the guidance from that partner. Those folks are the individuals doing testing day in and day out with the Exchange product and other server applications, and they know best what the impact is from a CPU perspective and really from any other resource perspective of running those applications on their hypervisor. So Totally recommend following their guidance and making sure that you're aligned with their best practices as well as ours. Absolutely the best way to size Exchange, regardless of virtualized or physical, is via the role requirements calculator that I have a link to on the screen here. And you can specify server role virtualization as yes. That'll add, by default, the 10% overhead to your CPU requirements. And then there's an additional parameter there, the hypervisor CPU adjustment factor, that you can use to configure the calculator for a different hypervisor. So around other resource impacts, in general, we don't think memory is going to be impacted very dramatically. There's a lot of different ways that you can configure memory utilization on hypervisors today, typically around NUMA configuration, non-uniform memory access. Exchange isn't actually NUMA aware. The Exchange services that run as part of an Exchange server are not aware of NUMA topology information that's passed down from the operating system. So though modern hypervisors are able to provide that information down to the OS and then down to the application, we don't take advantage of that. There are advantages from a NUMA perspective that come from the operating system and the way the operating system schedules work on different processors. So Exchange can certainly take advantage of that. And in general, the guidance here is to just follow your hypervisor vendor's recommendations for how to configure those NUMA settings, those memory settings. And you should have the best possible experience with Exchange. From a storage perspective, optimize for I/O latency and high availability. That's the same as it would be for a physical deployment and is very straightforward. And in general, across the board, size using the guidance for physical, and then apply that to a virtual deployment. Think about the ways in which resources are virtualized, and basically take the resource requirements that come from our guidance and apply those to your virtual infrastructure. It is typical to have Exchange virtual machines co-located with other VMs running other workloads. And we think the best way to deal with that is to use reservation options that allow Exchange to be guaranteed the resources that it's sized for, so that it can get to those resources when it needs them during times of peak load or some other type of failure condition where Exchange is running hot. So the hypervisors that we typically see out in the field today all have great options for configuring resource reservations. We highly encourage you to use them, and highly encourage you to not overcommit resources in such a way that Exchange will be starved of resources when it needs them. We also recommend minimizing the number of users per host. We absolutely believe that scale out is better than scale up for an Exchange deployment. So keep that in mind. The higher the number of users per physical host, you could have a large number of Exchange VMs running on that physical host, the worse the impact is when a hardware failure occurs or when a failure of that hypervisor occurs. Everything fails. You need to plan for what's going to happen when that failure occurs, and you want to minimize the impact as much as possible. So rather than having a lot of Exchange VMs on a single host, ideally we'd like to see the fewest possible Exchange VMs per host and use the other hardware available on those hypervisor hosts for other workloads. We think that'll provide much better availability for Exchange in the long run. So this will be slightly repetitive as I go through the problem areas, but I'll cover them fairly quickly here. So when we think about common problem areas that come up, one of them is around placement of virtual machines and thinking about failure domains. So I mentioned that we don't want a large number of Exchange virtual machines running on a physical host for HA reasons. It's not just Exchange virtual machines either. It's any of the dependencies that Exchange has within a deployment. That's Active Directory, that's networking infrastructure, that's storage infrastructure. When you think about the type of hardware that you're typically using for a private cloud deployment, you may be running with blades, as an example, in your data center facility. Blades have some shared infrastructure and can be thought of as what we consider a failure domain. If you lose that shared infrastructure, perhaps a storage component or a networking component that's shared across those blades, what happens to all of the virtual machines running on all of those blades when that occurs? Are you actually going to be able to have a good experience with that failure? Very important to consider where virtual machines are placed in order to provide high availability. think about Active Directory, think about witness servers if you're using a database availability group, and just be prepared that stuff does fail. Hardware fails and software fails. It always does eventually. So, think through the different failure scenarios and understand for each one of those what will the impact be on your Exchange deployment and the resulting impact on your end users. I mentioned that we do support host-based failover clustering. One of the things that I want to make you aware of is that host-based failover clustering does not provide high availability for Exchange. And the simple reason for that is that the hypervisor layer does not have visibility into the health of Exchange. All it really can tell is whether or not the operating system is running and what the general resource requirements are of that virtual machine at any point in time. So host-based failover clustering can certainly do a good job of responding to a physical hypervisor host failing and bringing up virtual machines that were running on that failed host on another host. It's great at doing that. But when it's doing that, it's going to bring those machines up from a cold boot. It's basically starting from the boot screen, going through bringing up the operating system and then starting all the services. And to us in Exchange, that's not really high availability. High availability comes from a DAG, a database availability group, and being able to fail over at the database level between Exchange servers. And we think that if you do want to use host-based failover clustering, that's fine, and it makes sense to do that in combination with a DAG, with a database availability group. So you get your high availability from the DAG, and then host-based failover clustering will bring up the failed Exchange server virtual machines so that replication can start up again, so that those failed machines are able to take workload if another failure occurs. That's really the benefit around host-based failover clustering. So combine it with a DAG. That's the key point here. So I mentioned we don't support any sort of memory reclamation, dynamic memory, memory oversubscription technology with 2013. Exchange is not designed to deal with disappearing memory, with memory going away underneath the covers. So static memory config is the way to go. What actually happens with this sort of scenario is visible on this graph. So what I'm looking at here is RPC average latency on an Exchange server. So this is the measure of how long it's taking each activity that an Exchange server is performing for end users. And you can see that in the middle of the graph, we have a fairly dramatic increase in RPC average latency. If I look at the available bytes counter on the server, you can see that it correlates really nicely with that increase in RPC average latency. So what happened here is that the hypervisor that was responsible for this virtual machine decided that it needed memory for another virtual machine running on the same physical host. And it did what we call a forced working set trim of all the processes running on this virtual machine that resulted in Exchange losing access to a large quantity of the memory that it had allocated. And as a result, all of the actions, all the transactions that are being performed on this Exchange server are now taking dramatically longer, and that'll be visible to end users. This is another view of that data. And it basically shows the working set, the amount of physical memory of the store process in Exchange. This is a 2010 graph, but the same thing applies to 2013, dropping off dramatically when that memory reclamation occurred, relating to that time period of RPC average latency going up. So don't use any of those memory technologies. Statically assign memory for Exchange. And then just to quickly go through the last couple of items here before we get to questions. When we think about migration, the typical problem that we see with migration is actually around the amount of time that it takes to perform the final action within a live migration or a vMotion activity. And in that final process where that final bit of changed memory is copied from hypervisor host to hypervisor host, that virtual machine is actually technically offline. And this is usually a matter of a small number of seconds, maybe even milliseconds for a highly optimized deployment, but it can be longer for a number of reasons. And the goal here is really to keep that time period as low as possible. If it exceeds 5 seconds, that Exchange server running in a DAG will actually get evicted from the database availability group, and a failover action will occur. Basically, the databases that were running on that virtual machine will become active on another DAG node, and then the machine that went offline will then come online, thinking that it's still running, and there will be a period of confusion where things kind of work themselves out. That's not good. We want to avoid that as much as possible. So the idea here is really to minimize the amount of time that brownout period utilizes. Needs to ideally be on the order of a couple of seconds. And the way to do that is to use dedicated network infrastructure for running those migrations, at least gigabit. If you have 10 gigabit links between machines, if you can use some of that bandwidth for migrations in a dedicated way, that's great as well. The more bandwidth, the better for these, and the lower latency, the better. If you do need to adjust the timeout beyond 5 seconds, that is an option. And I show the PowerShell commandlets that can be used to do that. There's also similar parameters for DAG nodes that are in different subnets as well, that you can change if that scenario applies. These are the default settings: same subnet threshold of 5, subnet delay of 1,000. It's basically saying try 5 times with 1,000 milliseconds or 1 second in between those tries. You can increase either of those numbers. If you wanted to make it 10 seconds, you could change the 5 to a 10 very easily. We don't recommend going above 10 seconds. If you start to consider extreme changes to these timeouts, what you're essentially doing is reducing the ability of Exchange to respond to Exchange servers going offline. So if a server actually does go offline for some sort of a failure reason, this is the amount of time that it could take Exchange to respond to that and actually activate the mailbox databases on other nodes in the DAG. So if you made this an hour, you could run into a scenario where Exchange wasn't responding for an hour to a failure that occurred and wouldn't be providing high availability to your deployment. I mentioned that we don't support snapshots. I'm not going to cover that anymore, other than to say, because of the nature of snapshots and the fact that they're essentially time traveling. You have machines in a distributed system that are going back and forth in time. It doesn't work well with Exchange, and we don't support it. And around oversubscription of CPU, really critical to not oversubscribe CPU wherever possible. You can run into things like queue growth, increased IOPS in some cases due to content indexing getting behind, and RPC latency, and end users feeling the pain of transactions running slow in OA, Outlook, other types of workloads. So we really want to make sure that that Exchange servers get the resources that they're sized for when they need them. There's been a bunch of confusion around hyperthreading lately. Especially because we've specifically recommended for Exchange 2013 that hyperthreading be disabled. And that's really specific to physical deployments. I'm not going to go into the reason behind it here because it's a little bit unrelated to what we're talking about. But for a virtual deployment, we're totally fine with leaving hyperthreading on the hypervisor host. That's absolutely fine. We just want to make sure that the additional logical CPUs that show up as a result of turning hyperthreading on are not used for the sizing process. That you're only looking at physical CPU cores for sizing. So in the example I have here, I have 16 physical processor cores. There's 4 CPUs, 4 cores each. That gives me 16 physical processor cores. If I turn hyperthreading on, I see 32 logical processor cores. I want to use those 16 physical cores for sizing. The 32 are a bonus. They give me some percentage of additional CPU throughput, but I can't always rely on that additional CPU throughput, so it's not available for sizing. That's the key. And then just be aware that Exchange does some dynamic tuning behind the scenes, tuning of resource utilization. And if CPU resources are being changed behind the scenes, that dynamic resource tuning is going to have a hard time and likely will not provide a great experience for you as a server administrator, and potentially have some impact on end user experience. So virtualization absolutely supported. I say in the slide here a few limitations. I always get some feedback that you just spent an hour talking about all the limitations, so how can you say there's few? Well, when you compare all of the options that are available and all the features that you get from a virtual deployment, the things that I described are actually fairly small, a fairly small subset versus all of the other things that you can do with a virtualized Exchange deployment. So keep in mind, not always the right choice. Don't oversubscribe resources, and there are features in current hypervisors and new versions that will come out in the future that don't necessarily make sense for Exchange. Think about how Exchange is being used, you administer Exchange, you're getting your high availability, and consider whether or not that new shiny feature actually is going to add anything or potentially add complexity and cause problems in the future. So with that, I will take questions. We've got at least 5 minutes. I'm happy to go a few minutes over as well. So I will let Josh kind of take over here and manage the Q&A process.
Great. Thanks, Jeff.